This is Ham College, episode 23 for November 30th, 2016. Ham College is brought to you by ICOM. ICOM has an array of radios to fill your stockings or place under the tree. And by hamstudy.org, a great way to study for your next exam.
And we're back. Finally.
Yeah, welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we've got some more questions from the technician pool for you tonight.
All right.
And a little history lesson. Tommy's going to school you on a thing or two.
Yeah, we're going to take you to school. So, we ought to be getting down pretty low in the question pool.
We're getting down pretty low in the question pool. I didn't count. I wanted to, but didn't have enough fingers.
So we got at least enough for another show then. We had more than you.
Yeah, it's a little more than another show, but it's whittling on down toward the end. And based on tonight's questions, I'm just going to fess up here. They're not going to be the most exciting questions that we've had.
But they are the questions, so we don't make them up.
We don't make this stuff up, no.
Yeah.
Most of the time.
Yeah. Well, yeah, we don't make all of it up.
Yeah. Well, Tommy, what did we talk about last month?
I think we had another round of just basically electronic questions for the most part.
I think so. And being as I didn't go back and look to be sure, I'm going to say, yeah.
Well, that's what we had.
That's what we had.
Yeah.
And it was. And we're going to kind of have some tonight, but these are going to be a little different.
Yeah, they're a little different. They're pretty easy for the most part, I think, if you get some basics down.
Yeah. And there weren't a lot of questions like this on the exam, so it'll be good to get them all out, get them out of the way. If you learn these few here, then that's, really all you're going to need to pass your technician exam.
Yeah. So we're getting near the end. Those of you who are on the fence, haven't gone to take your technician exam yet. It's getting about time.
It is getting about time, yep. And those of you who have, we know there's a lot of you out there that have taken the exam, didn't wait till we got through all the questions, and congrats.
Yeah, congrats.
Welcome to the hobby. And we've got a few new ones here in the chat room, too, I think, have not taken the exam yet. We want to encourage you, to do your studying. Check out hamstudy.org as well. Bone up on it before you go take your exam there. And find a session in your area where they'll be giving the exams.
Yeah, absolutely. You mentioned something that's interesting that we haven't touched base on yet, the chat room. So we disabled the YouTube chat because there were some hijinks going on in there. And,
well, I wouldn't even call it hijinks.
Yeah, well, I was trying to be nice about it.
Yeah.
But if you want to join us on the chat room, the URL is on the screen right now. So come join us, and we've got a nice little crowd over there, and it's a lot of fun. We check in on that throughout the show. Yeah,
AmateurLogic.TV/chat. There's a bunch of folks in there, and they're having way too much fun.
They are.
But, we just kind of let them go at it.
Yeah, that's good. That's good, clean fun in there, and anyway, come join them over there.
Yeah, and good clean fun, unlike what was happening.
Unlike the YouTube chat.
Yeah, I know. I think most people that use YouTube as a live streaming platform have turned off that chat because there's, just can't really control it. So, first question tonight: what component is commonly used to change 120 volt AC house current to a lower AC voltage for other uses? A variable capacitor.
B, a transformer.
C, a transistor.
Or D, a diode.
Well, Tommy, what do you think?
Well, it's not going to be D, a diode. I'm sure of that. And it's not going to be a transistor either. I don't think you run 120 AC volts into a transistor.
No, some you might could, but
Really?
I don't know of any runoff. No.
Okay. Variable capacitor seems plausible, but I know the answer is a transformer.
Yeah.
From previous experience. So transformer will take the voltage and step it down or up.
Or up, depending on which way you put it.
Mm-hmm.
We've talked about them before, so let's see. Yep, transformer.
Yep.
All right, I wish I had one sitting right here we could look at, but I think probably most of you know what it
Take one
looks
out of
like.
something real quick.
Yeah, I've got a whole drawer full of them over there, but we won't get that out now. Basically, it's a bunch of turns of wire on one side and a bunch of turns of wire on the other side. And you have more turns on one side than the other side. If you're putting voltage in on the side with the most turns, the other side has a lower voltage.
Okay.
If you flip it around, put a voltage in on the side without many turns, the side with a lot of turns is going to step the voltage up.
Cool. Yeah, it's pretty interesting little device.
Yep. If it's the same on both sides, it's a 1-to-1 or an isolation transformer. Well, you got a question for me?
I sure do. Somewhere up there. What is the name of a device that combines several semiconductors and other components into one package? A transducer.
B, a multipole relay.
C, integrated circuit.
Or D, transformer.
Well, I already helped you out on one of those.
I think, yeah, maybe you did a little bit. What is the name of a device that combines several semiconductors and other components into one package? All right, semiconductors, that's like transistors. So, it's not a transducer is like a microphone or a speaker or a piezo buzzer or something. It's not that. It's not a multipole relay. You know, a relay, we've talked about those before.
We talked about those last month.
That's just a mechanical switch controlled by an electromagnet. So no, that's not semiconductors. It's not D, a transformer, because we just talked about that being
we
coils
just
of
ruled
wire.
that out.
So all we got left is an integrated circuit, and I think most people here would guess that. Integrated circuit is a lot of different transistor and semiconductor circuits all in one little package. There we go.
You nailed it.
Integrated circuit. Okay, we've got another one here. I believe this is a semiconductor too, Tommy.
Oh, yeah?
Yeah. What does the abbreviation LED stand for? A, low emission diode.
B, light emitting diode.
C, liquid emission detector.
Or D, long echo delay. I don't know what a long echo delay is, so I'm scratching D off that list. And the low emission diode, I don't even know what that is either. Liquid emission detector, let's go ahead and make that three things that I don't know what it is. So I'm down to B being the answer. Light emitting diode.
Yeah, well, that's what everybody's saying over in the chat.
And I was actually shopping for some of those on the internet last night.
You were. We talked about that, didn't we?
Yep.
Well, let's see if you're right. LED stands for light emitting diode. That's correct, and I don't think we need to show what an LED is. I think most people are
Most people
familiar with
know.
those little.
But if you're
Solid
not,
lights
look at the front of your computer and the light bulb that's on, good chance that's an LED.
Yep.
Oh, wow, this is kind of cheating. Which of the following is commonly used as a visual indicator? A, LED.
B, an FET.
C, a Zener diode.
Or D, a bipolar transistor. What's commonly used as a visual indicator? Bipolar transistor. No, that's a semiconductor, but doesn't put out any light. A Zener diode, that is a type of diode, but it doesn't put out any light. An FET is a field effect transistor. It doesn't put out any light
either.
But an LED, that's a light emitting diode.
We pretty
It
much
Kind of rings
that's
a bell.
2 in a row that I've given you.
Well, I'll take it. Well, let's get set up here for a little history lesson.
Okay.
Let's take a break real quick, get a message from our friends at ICOM while you and I scurry about and shuffle things together.
Sounds
prepare
good.
for this.
Holiday season is here. Looking for the ideal gift for your favorite contester? The holidays are just around the corner, and ICOM has an array of radios to fill your stockings or place under the tree. Perfect for the contester on the go, try the IC7300. It's a high-performance, innovative HF transceiver with compact design. The real fun starts here. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. Push performance to the pinnacle with the IC7600. Following in the footsteps of ICOM's flagship radio, the IC7600 offers intuitive operation and the latest DSP technologies. Digital IF filter, dual DSP, 5.8-inch ultra-wide TFT display, and high-resolution real-time spectrum scope. Raise the bar with the IC7851. Hear what others cannot with this HF 50 MHz transceiver. Reciprocal mixing dynamic range, crystal clear local oscillator design, spectrum scope, dual receivers, digital voice recorder, and more. To learn more about these and all of ICOM's great radios, visit ICOMAmerica.com/amateur today.
And we want to thank ICOM for sponsoring Ham College, making it possible.
Absolutely.
Tommy, when we do that ICOM commercial, there's usually something we do right after it.
It sure is.
And there it is.
Just so happen to have it right here. It's time for a giveaway.
Okay.
Let's give away an ICOM ball cap and a nice ICOM Ham Crew t-shirt. So I hope you guys sent your name in for the drawing.
And where would they send it to?
You would send it to Ham College at AmateurLogic.TV. Hopefully we'll draw your name.
Don't have to have a call sign, don't have to be an amateur.
Oh, no. No, you don't have to have a license to wear one of these.
Just drop us an email and say, hey, I'd like to win. And your odds are good, you know. So do that. As a matter of fact, I say your odds are good. The reason I say that is because last month's winner, we just happened to have proof right here. There he is.
Yeah, look how sharp you'll be looking if you win one too.
Yep. That came from Milan into NYU. And he says, as promised live in the chat room, because he was watching in the chat room when he won this. He says, I've attached photo with the ICOM shirt and hat.
Awesome.
Congratulations, Milan.
It looks nice.
I notice he's got an oscilloscope in there.
I saw that.
So he's not just a casual observer then.
No. He's probably opened up some of that gear a time or two.
It's a good chance, I would say.
Yeah.
Cool. Well, Tommy, who do you think we should give this to tonight? Because as true to form, I have not drawn a winner yet.
All right. We going to do the rock, paper, scissors thing, or are you going to do a random number?
I'm going to do a random number. We've had a few more entries in here. Showing these pictures, I think, are increasing
the
number of contestants we have here. So let's just see. Tonight's lucky winner, it's Don Rhodes, KB2YSI. Don, congratulations. He said, please throw my name in the hat for the shirt and hat drawing.
Well, congrats, Don.
Don, we threw it in there and it stuck.
Yeah, if you feel so inclined, send a picture with your swag on and we'll show you on the show.
Yeah.
Yeah, it's always cool to see those.
All right, well, without further ado, I guess we ought to get on into the lesson for tonight.
Oh, we're about ready to go to class?
I think we are.
All right.
So, Tommy, what are we going to talk about tonight?
Tonight, we just so happen to have a plethora of questions on decibels. So,
I'm glad the way you were so familiar with the topic we were going to talk about.
So, so let's just get on with it then.
Okay, who is Decibel?
Decibel. First of all, what is a decibel? Decibel measures the ratio of power or intensity. It expresses them as an exponential function. 1 bell is a power ratio of 10 to 1 and is divided into 10 decibels. An increase of 3 decibels is approximately a doubling of power. That's an important point too, because in a lot of things we do, that's very important. I'll say that again. An increase of 3 decibels is approximately a doubling of power. Decibels are often used in measuring telecommunication signals. With electric audio signals, there are several decibel units relative to several bases. For example, dBm is relative to 1 milliwatt. I think dBm stands for decibels to milliwatts, if I'm not mistaken. It's been said that the smallest difference humans can hear is 1 dB or 1 decibel, and is related to the absolute threshold of hearing. Although that's very subjective at best. And the absolute threshold of hearing is the lowest amount of audio that your ear can detect. A person with good hearing.
Yeah, unlike us.
My hearing's actually pretty good. I just can't remember what I've heard. So the memory, they say the memory is the second thing to go, but I can't really remember what the first is. So
I don't think we want to talk about it.
So a bell, the Bell unit was named after Alexander Graham Bell. This unit was so rough that it's more typical to use the decibel, which is 1 bell divided by 10. Before bells, there was a transmission unit, or TU. The decibel, or dB, is used within electronics and associated industries to provide a method of indicating the ratio of physical quantity, often electrical power, intensity, current, or voltage. Decibel uses base 10 logarithms. Those are commonly used within mathematics. As it can be seen from the name, decibel is actually a tenth of a bell, a unit that's seldom used. So that they rarely use the bell unit. It's almost always decibels. Abbreviation for decibel is dB. The capital B is used to denote the bell as the fundamental unit. The decibel is widely used in many applications. It's used with a wide variety of measurements in the engineering and scientific areas, particularly within electronics, acoustics, and also within control theory. Typically, the decibel is used for defining amplifier gains, component losses, on attenuators, feeders, mixers, etc., as well as a host of other measurements such as noise, signal-to-noise ratio, and many others. You see decibels referenced a lot in antennas, the gain on your antennas and your amplifiers and so forth, a lot in the ham radio stuff.
I was going to say on VU meters, but no, that's actually a dB meter or a decibel meter.
dB,
There's a difference between VU and dB on those meters.
Yeah.
Although you will see a lot of meters that actually measure dB called VU meters, and they're not. They're decibel meters. But
So what does VU stand for?
Volume unit.
Volume unit.
Which is very similar. It's just a slightly different scale. And we won't get into that.
So I haven't seen a meter actually in decibels in a long time. Do you have any?
Here's one right here.
Well, I know that.
Yeah. I think that little mixer up there in that rack says dB on the scale there, but it's actually a VU meter.
Oh, yeah. Cool. I don't think I've got anything with it.
Yeah. Well, I've got a little chart here, and we're going to do a little explaining. And this could come in handy. So let's look at it here. There's a difference between decibels when you're talking about a power ratio and a voltage ratio. They're not the same. Here, we're going to be talking about power ratios. That's what we're interested in for our exams. That's what the questions are going to be about. So if you had a signal that was 0 dB, then you would multiply whatever that was by 1, which means it's the same thing. There's no change. However, if you're looking at 3 dB of loss, in other words, minus 3 dB, you'd multiply that number by 0.05. So that means if you cut a signal by 3 dB, you've cut it in half, basically. Or if we're talking about power now. If you increase the signal by 3 dB, you're going to multiply it by 1.995, which is approximately 2, which is what you said a moment ago. All right, so basically, 3 dB means that we double the power.
Mm-hmm.
All right. Look here at 10 dB. If we do it 10 dB, well, that just happens to be, that'd be 10 times the power.
Yeah.
All right. Well, and the reason I point that out is when we're talking about amplifiers, particularly audio amplifiers here. Say if you've got a 10 watt amplifier, what if we increase that to 20 watts?
Oh.
Well, how many dB would we have increased it by?
That would be 3.
3 dB. But that would be just barely enough that you could notice a difference on stereo. If you wanted it to be twice as loud as that 10 watts, you're going to need 100 watts. You're going to need to go 10 dB.
Interesting.
So just a little something to keep in mind there when you're thinking about decibels. So let's get on into a few questions here on them.
It's an interesting topic.
It is. And our first question on decibels tonight. Tommy, I don't know who read the last one. I think it was you.
Okay.
So I'll ask you this. What is the approximate amount of change measured in decibels of a power increase from 5 watts to 10 watts? A, 2 dB.
B, 3 dB.
C, 5 dB.
Or D, 10 dB. Well, we just kind of reviewed that, so we're going to go from 5 to 10 watts. That's double. So we just said that's 3 decibels.
3
is
decibels
a double.
is doubling the power. We're talking about watts here, so that's power, which is what
that's a
we're
measurement
looking
of
at.
power. So I'm going to say it's B, bravo, 3 decibels.
Well, let's see if you're right, and you are, and so is everyone else in the chat room. Except the cheap old man, and he said it's D and B for dB.
But he's got a lowercase d and a capital B.
Yep, and that is the way that you normally see
that's
it written. Yep.
Well, cool.
Okay, that one was easy enough, Tommy.
It was.
Now you got one for me.
Yeah, I'm going to throw you a curve here. What is the approximate amount of change measured in decibels or dB of a power decrease from 12 watts to 3 watts? A, minus 1 dB.
B, minus 3 dB.
C, minus 6 dB.
Or D, minus 9 dB. All right, I got to think about this one a little bit here. Let's see. What is the approximate amount of change measured in decibels of a power decrease from 12 watts down to 3 watts? So that means I'm cutting it in half once. That would make it 6 watts.
Mm-hmm.
All right. But I'm cutting it in half again to get 3 watts. I'm going to say minus 6 dB, Tommy.
Yep, I think you're right.
So you see how I did that there?
Yeah.
Pretty easy.
So that for each 3 dB we can have
cutting it in half. All right. Well, let's see. And that's correct. It's C.
Yeah.
You know,
These, at least there's some reasoning to some of these. Some of the ones that we've had over the last, I think, 2 months or so, you just have to memorize a lot of those. But there's some reasoning, some math behind these, which makes it a lot easier. If you just get the basic theory down, you pretty much got it.
But the way I worked that out in my head without using a decibel chart was just, you can't take the 12 and divide it by 3 and say, well, that's 4. That's not the way it works. Take the 12, divide it in half once, and you've cut it by 3 dB. But that only got us down to 6 watts. So divide that in half, get down to 3.
You just have to know
so that's
half.
another 3 dB.
So that's your reference. Half to reduce it, half is 3 dB. Or if you're increasing it, doubling it is 3 dB.
Yeah. But
so
you got to do it in stages.
Yeah, that's your point of reference. So it's logarithmic. So it's this much, then it's this much, then it's that much. Just like that.
Yeah. What is the approximate amount of change measured in decibels of a power increase from 20 watts to 200 watts? It's A, 10 dB.
B, 12 dB,
C, 18 dB,
or D, 28 dB? Well, we just reviewed this also, so it's we basically already went over the answer. So I'm going to say that it's going to be A, 10 dB, because that's 10 times.
So you're saying it's A.
So I'm saying it's A.
And that's what everybody else in the chat room is saying too. I think
And this
you're
is
all right.
almost the example you just gave earlier.
It is
it's
almost.
it's very close.
Very close to it. Yeah.
So I had a little
go.
bit of cheating on that one.
10 dB.
10 dB.
And you know, that's all the questions you got about decibels.
No way.
That's
I was
it.
just getting warmed up too.
I know, but that's it. So if you can remember 3 dB and 10 dB, you just got to know which question they go with.
Yeah.
Well, you got to remember 6 dB too now.
You just need to know the little basic math.
Yeah,
It's super simple.
yeah.
So
And the odds that you're going to get all 3 of those questions is pretty high. You might pull 1 decibel question, or you might not have any on your test. You know, just depending on how the exam falls for you. So let's go on to.
it's still good stuff to know in practical application also when you're looking at antennas and
Oh, yeah.
different
Yeah.
things. So it's great stuff to know.
Yeah, so somebody says that I'm going to increase my power 3 dB, they're going to double it.
Mm-hmm.
They
So your
say,
antenna, my antenna's got 7 dB of gain,
mhm.
so it's going to be effectively 4 times.
Yep. If somebody says they're looking at the S meter on their radio, and they say you're 20 dB over zero, in other words, you're on that plus 20. That doesn't mean that you're 20 dB over. That's S units.
Mm-hmm.
You're 20 S units over. That's not the same exactly as
Yeah, but
dB.
they'll say dB every
Yeah.
day,
Yeah.
pretty much.
So just a little something to be aware of on that. So now we're going to talk about some metric stuff, and we need another chart to do that with. We're going to talk about tera, giga, mega, kilo. We're going to skip hecto and deca because we don't use them really. You could, but we don't in electronics. Deci, we just talked about deci.
Decibel.
But we're not going to use that. And we're not going to use centi, but we're going to use milli, micro, nano, pica. So these I've got highlighted here are the units that we use for capacitors, resistors, frequency. Whenever we're talking about electronics measurements,
Watts.
these are them.
Like
watts.
1.21 gigawatts.
Yep. Let's say farad is a unit of capacitance.
Mm-hmm.
So if I have a 1 farad capacitor, that falls right here. It's just the basic unit. But let's say I have a 100 microfarad capacitor.
Mm-hmm.
That's going to be down 1, 2, 3, 4 levels here.
Yep.
That's going to mean that is 1 microfarad is going to be 1 millionth of a farad, which means you would take whatever that number is and multiply it by 0.000001.
Wow.
So basically what I'm trying to say is 1 microfarad would be 0.000001 farads. Capacitors, you'll also see them occasionally referred to as picofarads. Well, that's to the negative 12. So 1, 2, 3,
Is that
4,
common?
5, 6, 7, 8, 9, 10, 11, 12. That is common.
Wow.
Yep.
Yeah.
Yep.
That seems awful small.
But that's the truth. You know, used to when when I went to college, the instructor told us a 1 farad capacitor would be the size of this room here. Well, technology has improved, and no, that it wouldn't be that big anymore.
Mm-hmm.
But still 1 farad is a tremendous amount of capacity. So we're normally, when we're talking about capacitors, we're talking about microfarads and picofarads, values like that.
Well, that's true. You say that. Back in the old air conditioned days, I remember getting like 440 microfarad capacitors for a compressor.
Which would be a pretty good size.
Yeah, it was like a beer can, size of a beer can.
Yeah. Back to the chart here. Let's talk about resistors. So if you had a 1 ohm resistor, that's just a 1 ohm resistor.
Mm-hmm.
What if you had a 1 k ohm resistor or a 1 kilo ohm resistor? That would be 1,000 ohms.
Mm-hmm.
So you would take 1 times 1,000. 1,000 ohms would be the same as 1 kilo ohm.
Yeah.
All right. What if it's a 1 meg ohm resistor? Well, that would be 1 million times.
That's a lot of resistance.
That's a lot of resistance. You could even have a giga ohm. That I don't know that I've seen giga ohm resistors, but there is such a measurement. And you could even have tera ohms or terahertz or tera anything really, but
Terabytes?
yep. So metric conversions there is something you're going to need to know about. We'll come back and look at this chart though as we get to the questions that they relate to.
All this metric stuff is it's actually pretty easy once you get the basics down.
Mm-hmm.
Basically the scaling of it. Do you remember back when the country was going to go metric, and like everybody had a fit?
Yep. Didn't really happen, did it?
Alabama actually went and changed all the road signs out, and then they had to take them back down and put the other ones back up. But they were ready to jump on, both feet. But pretty much most of the country had a fit and didn't.
Yeah, Alabama's just always ahead of everybody else.
Bleeding edge. We were on the bleeding edge, man.
Yeah. I do. Well, I don't have one here, but a lot of things here will have both U.S. and metric designations on them now, like can of Coke.
When I did the first 3D printer thing, I had some comments, some emails, people talking about how I used metric measurements in millimeters when I was drawing it out instead of using the standard.
It's really easier if you're measuring stuff.
It is.
Yeah. But if you're thinking about how long's a foot, I can tell you how long that is. If somebody said, how long is 25 meters, I'd have to think about that a minute.
That's okay. You just think about it a couple times, then you'd have it.
Yeah.
Which of the following frequencies is equal to 28,400 kilohertz? A, 28.4 megahertz.
Yeah, B, 2.800 megahertz.
C, 284.00 megahertz.
Or D, 28.400 kilohertz. Well, let's go over these here. We'll start at the bottom. 28.400 kilohertz. No.
Too bad that's not a comma.
That's not it. C, 284.00 megahertz. Now that's 284 megahertz. That's way more than what we're talking about. 2.8 megahertz. That's not it. I'm going to say, Tommy, let's look at our chart here and let's figure it out with that.
All right.
Right here, if we look at the line for kilohertz, that is 10 to the third. If we look at megahertz, that is 10 to the sixth. What that means we need to do is move the decimal place over by 3. So let's go back to our question there. 28,400 hertz. We need to move the decimal point, which is right now at the end of that, right after 28400 decimal point. That's how many kilohertz we're looking at. If we move it 3 places to the left, that's 28.4 megahertz. All right, so that's going to be answer A there.
Yep.
You think we got them thoroughly confused now?
Probably so.
So there you go, 28.4 megahertz.
Emil's still rooting for the buzzer.
Yeah, I don't know. You'd think by that last one it could happen,
Yeah, it could.
Well, let's go on to another one of these kind of questions.
I'm going to have to bring some binoculars next month.
Yep. How many volts are equal to 1 kilovolt? A, 1/1000th of a volt. I just caught what you said.
B, 100 volts.
C, 1,000 volts.
Or D, 1 million volts. How many volts are equal to 1 kilovolt?
You want to look at this chart here?
Well, let's see what we can do with that. 1 kilo is 1,000.
Mm-hmm.
To the third power. So let's go back to the question. 1,000 volts, C.
Okay. And that's what everyone over in the chat room is saying. And we know how smart
It's a
they
darn
are.
good thing you brought this chart.
You don't think you would have got
Yeah.
Yeah, I know you would have, but yeah. Kilo is 1,000. Mega is 1,000,000. Giga is 1,000,000,000. And what's a trillion? Yeah, I see you looking at the chart.
Tera?
Tera.
I know that. I should know that.
But that's not going to come up on your exam here. So you don't have to worry about
Still
those
good to know.
up there. Yep.
But everybody that's got a terabyte hard drive in their computer probably knows that.
Except we won't get into that they're not base 10, but
Yeah.
we'll just skip that.
It's close
whole-
enough.
Yeah.
They usually just round it anyway.
Yeah.
Get ripped.
All right, you got one for me?
Sure do. If an ammeter calibrated in amperes is used to measure a 3,000 milliampere current, what reading would it show? A, 0.003 amperes.
B, 0.3 amperes. Or C, 3 amperes.
Or D, 3 million amperes.
Well, I hate to even think about that, what 3 million amperes would look like. Okay, an ammeter calibrated in amperes used to measure a 3,000 milliampere current. What would the reading be? Okay, let's go back to our chart there. We're talking about milli. So that is 1,000th, which is a -3. That means we've got to move our decimal place to the left 3 positions there to turn milliamps into amps.
Mm-hmm.
Because the meter's calibrated in amps. So that would be 3.000 or 3 amperes. It'd be C. Do you agree?
Yes, I do.
Okay, and that's what they're saying over there in the chat room. So, yep, 3 amperes. And I've got one for you now.
All right.
How many milliamperes is 1.5 amperes? A, 15 milliamperes.
B, 150 milliamperes.
C, 1,500 milliamperes.
Or D, 15,000 milliamperes. 1.5 amperes, how many milliamperes? That's going to be 1,000, I think it's going to be 1,500 milliamperes.
Well, that's what the guys in the chat room are saying, and I'm kind of inclined to think that
Maybe onto something?
if more than one of them said it, yeah, it's a good chance. So, yeah, I think it's going to be C, 1,500 milliamperes. There you go. You're just moving that decimal place to the right there. 3 positions.
How many microfarads are in 1 million picofarads? A, 0.001 microfarads.
B, 1 microfarad.
C, 1,000 microfarads.
Or D, oh, what is that?
That's 1 trillion microfarads.
1 trillion microfarads. Okay, well, yeah, I'm going to pull out the chart here. Microfarads we were talking about, that is to the millionth. And picofarads, that's down here. That's a trillionth. So that's to the -12. So that means right now, microfarads, we're sitting at -6. We need to go to -12. we've got to move that decimal place over 6 points. We're going to move that decimal place to the left. So 6 points, I'm
Is
going to
that
say
right?
that's 1 microfarad.
Wow.
Doesn't seem like many, does it?
Nope.
Let's see if we're going to use the buzzer. That's going to be answer B, 1 microfarad.
1 microfarad. There it is, black and white.
Yep, that's what everybody said in the chat room there. So 1 million picofarads, same as 1 microfarad. Let's have a brief intermission here. We've got something fun to look at.
Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stufflebeam, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam.
Hey, let's take a minute and meet Clark Kent, of Superman.
Chief, believe me, you're in for a treat just as soon as Jimmy gets back here.
Great Caesar's ghost. What's holding him up? You know I can't work without a good breakfast.
Chief, Jimmy's bringing a box of Kellogg's Sugar Smacks.
All the more reason for hurrying. Confound it, that boy knows I like those new Sugar Smacks.
And he knows I do, too. And that's a cinch.
Well, here I am. Young man, if you spill those new Sugar Smacks, you're fired.
Golly, Chief, I hadn't opened up the box yet. But I'm going to now.
Well, I guess we all agree on Sugar Smacks.
Right.
Folks, don't wait. Get Kellogg's new Sugar Smacks. They're better than ever. Puffs of wheat, sugar toasted, and candy sweet.
You bet. Just get Kellogg's Sugar Smacks, brand new.
A Northwest Mountie, and he's been trailing this desperate character for 3 years.
And I'm tired. Well, it's him or me.
Uh-oh. He's got an aching head, an upset stomach,
and an empty gun.
What you need is some Alka-Seltzer. You know what they always say.
Yeah, a Mountie always gets his man.
Oh, no, I mean about Alka-Seltzer. Relief is just a swallow away.
Well.
Down, 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 the stomach through. Round, 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 the system too. With Alka-Seltzer, they always say, relief is just a swallow away.
Bless that relief-giving Alka-Seltzer.
For that headachy, upset feeling, take Alka-Seltzer. Relief is just a swallow away.
Hi, kids. Look at some delicious magic with the extra good chocolate-flavored syrup, Bosco. Now watch. Take ice cream, spoon on extra rich, extra thick, extra chocolatey Bosco syrup. There's the best chocolate flavor you ever tasted. More Bosco magic. Cake, ice cream, topped with extra thick, extra chocolatey Bosco syrup. Try it. Bosco also makes milk chocolatey delicious. Tell Mom to get Bosco chocolate-flavored syrup for you. Sing out,
I love Bosco, it's rich in chocolate tea. Chocolate-flavored Bosco is mighty good for me. Mama puts it in my milk for extra energy.
Bosco gives me iron and sunshine vitamin D.
Oh, I love Bosco, that's the drink for me.
That Alka-Seltzer guy was kind of dangerous waving that gun around, man.
He was, and that clown was kind of creepy.
Yeah, that's
too.
creepy.
Yeah.
But and that candy sweet cereal. You know the kids gotta love that.
Yep. Well, you know, that's not the original ones that I was going to edit and put in there this time. I got to look at, I had edited in some other ones, and then I looked at it and I said, no, I'm not going to run those because it was an advertisement for Colt 45, Lucky Strikes, and Territon. I said, no.
That's not the best ones for the young crowd.
Yeah.
Not that kind of show.
Yeah, but you're sitting over there with a Breaking Bad shirt on, so
well, that's true. I forgot to change it.
How many volts are equal to 1 microvolt? A, 1/1,000,000th of a volt.
B, 1 million 1,000,000 volts.
C, 1,000 volts.
Or D, 1/1000th of a volt. And back to the old trusty chart. It said micro. Did it say micro? Yeah, I see it. Microvolts. Micro. That's going to be right here. And that's going to be millionth. Okay, so I think we have our answer.
Let's see, that's the -6.
A, 1/1,000,000th of a volt. It's a microvolt. It said millionth right here.
All right, they're all over the place in the chat room. We could be using the buzzer. We got an A, a B, a D, and an E. Well, let's just see, Tommy. Do we get to use the buzzer? No, we don't.
The chart doesn't lie. When you can read it right.
Yeah, that's the big if.
Yeah.
1 microvolt is 1/1,000,000th of a volt.
Yeah.
That one was too easy.
Well, it's right there on the chart, man.
Well, yeah. Okay.
They're all easy when you look at the cheat sheet, the chart.
Yeah.
Which of the following is equivalent to 500 milliwatts? A, 0.02 watts.
B, 0.5 watts.
C, 5 watts.
Or D, 50 watts.
This one's too easy.
Well, right off the bat here, I'm going to say it's not A because we're talking about a 5 in the
So
number
it should
there.
be something with a factor of 5.
So what's equivalent to 500 milliwatts? Milli is thousandths, so that's to the -3rd there. If we moved the decimal place to the left 3 points there, that's going to tell me it's 0.5 watts, which is B.
There's your answer.
I'm going to say it's B. And that's what they're saying over in the room there, so there we go.
Nice job of working that chart there, Professor Thomas.
Thanks, Dean Martin. Although you should really be the professor with the flask on.
Yeah, chemistry professor.
That's it. That's all the questions for this week.
It's just getting warmed up, too.
Yep. And as luck would have it, that's all the questions you're going to have like that on the exam.
Oh, yeah?
Yep.
So we're into next month, we'll have something
different.
Yeah. Cool.
Yep. Not sure what it is because I didn't look that far, but that's all the ones like this.
But there'll be some for sure.
I sure hope I'm not lying too, because I think that was all like this.
Okay. Well, we'll find out.
Yeah. Okay. Well, the slide says chat there, Tommy, and that means that
let's turn to the chat
see
room.
what's going on in there. Yep. AmateurLogic.TV/chat. Okay, any questions in the chat?
That was a comment. Tommy should wear a bow tie for this show because bow ties are cool. Bow ties are cool, but I don't even own one.
You'd need a clip-on.
Yeah. And now for something completely
Kelly
different.
says she wants to go through more questions. More questions? All right, Kelly, I'm going to pick out a random question here. What do you say? She wants more questions.
More questions?
Let me just pick out a random question here. I'm just going to look in the book here. I'll read it out since we don't have a slide for this.
Is this one of the unused questions?
This is an unused question.
So you're getting a sneak peek into next month.
Maybe.
Possibly.
I don't know how far it may not be next month. Maybe 2 months. I'm not sure, but it's one that'll be coming up in the future. Oh boy, this is going to be a tough one too, but it's the first one I tuned to. How does RF radiation differ from ionizing radiation, radioactivity? A, RF radiation does not have sufficient energy to cause genetic damage. B, RF radiation can only be detected with an RF dosimeter. C, RF radiation is limited in range to a few feet. Or D, RF radiation is perfectly safe. Wow. I think we could use
Okay,
the
Kelly,
buzzer.
what's the answer?
Yeah, Kelly. What's the answer? I didn't remember any of them being this hard on the technician exam, Tommy.
It's not perfectly safe.
So it's not D.
It's not, and it's not limited to just a few feet.
Yeah, or else the radios wouldn't work very good.
And B was detected with a dosimeter, which I think that's a Geiger counter, isn't it?
I'm not sure if that's, yeah, it might be the
I
same.
think the answer is going to be A.
RF radiation does not have sufficient energy to cause genetic damage. And Tommy, you would be correct.
Genetic damage.
And that's what most of the folks are saying over there in the chat room.
Oh, cool.
Yeah. So, I think one extra question's enough for this month, Tommy, because that was.
Yeah, I don't know if I could do another one of those.
No. All right, thanks for being here, y'all. 7-3, join us again next month. Around the end of the month, and AmateurLogic around the 15th. Don't have the exact date yet, but we'll be posting it.
Yeah, watch the social media outlets, and we'll post a little bit ahead of time there.
All right.
73, everybody. See you next month.
Or look right here at the end of this remote control. That's an infrared LED there.
You got ghosts over there.
Yeah, that was.
This isn't even the Halloween episode.
That was the spare pair of glasses. Say if you increase that signal by 3 dB, this doesn't make sense, does it?
Sure doesn't.
So it doesn't really matter. Why don't you ask this one? Oh, that's the wrong question.
That's a rerun.
Marty says, fun, fun, fun. Is that Autobahn song?
The what? I don't know that one.
Yeah. Not that kind of fun.
What happened?
Yeah. It just kind of
blanked out. Did you just black out too?
Yeah, I sure did.